All right. So number one, Abe wants to deposit the following into his savings account: 29 $1 bills, 7 $5 bills, 17 quarters, 21 dimes, 43 pennies, a check for 37.34, a check for 114.17, and wants to receive a $100 bill in cash. How much will he deposit? So you start breaking it down. So you got 29, $1, 7 times $5 for the bills that he's got. So 29 times 1, simple enough, $29. 7 times 5, 35. So add those together and we get $64 in bills. And then for the change, we got 17 times 0.25 for quarters, 21 times 0.10 for the dimes, and 43 times 0.01 for the pennies. So 17 times 0.25 give us 375. 21 times 0.10 is going to be $2.10. And 43 times 0.01 is going to be 43 cents. Add those together. And we're going to get $6.28. And add those and the checks together. So we got checks of 37.34, 114.17, and then all of our bills, 64, and our change, 628. We got 11 and 8 is 19, 4, 5, and 7 on 11, 15, 21. Carry 2, 5, 6, 12, carry the 1. So 221.79 is all the money that she's putting in there. But then it says that he's going to receive a $100 bill. So 221.79 and subtract the $100 bill, and 121.79 end up being our total deposit. All right, so number 2, Rosa has checks for $60 and $45. She also has 4 $20 bills. She'd like to receive $25 in cash and deposit the rest in her savings account. What's the total deposit? This one's a little simpler than the last one. So got checks for $60, $45, and she got 4 $20 bills. So 4 times 20, $80. So that's all the money going in. $185, and she wants to receive $25 back. So $160 will be her total deposit in there. All right, number 3, Norbert deposited one check into a savings account for $417.45, one check for $113, and a third check, the amount of which he cannot remember. His total deposit was for $917.54 after he received $100 in cash. What was the amount of the third check deposited? So we got to figure out how much his third check was for. We know that his total deposit was $917.54, which that deposit was made up of a $417.45 check, a $113 check, some check that he doesn't remember the amount of, so I'm going to call that X, and then he got $100 cash out, so that's subtracted from all that total. 917.54. Combine those numbers together there, and 417 plus 113 minus 100. It's really like 417.45 plus 13. We take 100 away from 113, so that's going to give us 430.45 plus X. So subtract 430.45 from both sides. And we get 487.09 is going to be equal to X, or that's the amount of the missing check. All right, number 4, write $534.57 in words the way you would if you were writing it on a deposit slip. So just really converting that dollar amount into words. So 534 and 57 $100s. Number 5, write 37 and 43 $100 as a numeral. So 37, 43. Simple enough, hopefully. All right, so then number 6, Alex savings account statement is shown below. What is his new balance? So the previous balance is $429.34. He had $3.27 in interest, $257.19 in deposits, and $132.18 in withdrawals. So interest and deposits is added on to the previous balance. Withdrawals is taken away, subtracted. So we've got $429.34, and we're adding $327 to that, and $257.19, and then subtracting the withdrawals, which is $132.18. And so 429.34 plus 327 plus 257.19, it's going to be 689.80, and we're subtracting 132.18 from that. It's going to equal 557.62. Alright, so number 7, Venus reviewed her account statement and wanted to verify that the interest amount was correct. Her new balance was $11,438.75, and her previous balance was $8,749.50. She had deposited $3,041.64 and withdrawn $307.21. Find the interest earned on Venus's savings. Alright, so you got the new balance, which is $11,438.75, and that should equal the previous balance, $8,749.50, plus the interest, and plus any deposits. And actually, when I drew this up, I actually put in the wrong value here so that the actual answer here is not going to be correct, but I'm going to work it out just like we should. So 3,041.64, and then withdrawing 307.21. So 87.49.50 plus 3,041.64 and subtracting 307.21. It's going to give us 7,483.93 plus I. So in this problem, I actually should have taken away $357 instead of $307, because right now our amount over here, before we add the interest, is actually greater than what we say our new amount is. So we subtract that out, which is what we would need to do to find the interest. And I end up with a negative number, which our interest should not be a negative number, so I'll have it correct on the test, but that's the process. So if you got a negative number, then you were not wrong if you thought you were wrong on that problem. All right, number 8. Francois deposits $450 in a savings account. The account pays an annual interest rate of 4%. He makes no other deposits or withdrawals. After 3 months, the interest is calculated. How much simple interest did his money earn? So I'm going to start with the $450. That's what he deposited. And to find the interest, we would need to multiply that by the interest rate for that much of the term. If the interest rate is 4%, but in order to multiply with it, to use it in the problem, we've got to convert it to a decimal, which means we move the decimal 2 places to the left. So it becomes 0.04. And then we're also looking at only 3 months, because the 4% is for an entire year, and 3 months is 3/12 of a year, or 1/4 of the year. So it's going to be 450 times 0.04 times what percent of the year, or what part of the year we've used, which is 1/4, or 450 times 0.04 divided by 4. Either way you want to look at it. And when we multiply that out, we're going to get $4.50. Number 9, Jessa deposits $365 in a savings account. The account pays an annual interest rate of 6%. She makes no other deposits or withdrawals. After 4 months, the interest is calculated. How much simple interest did this money earn? So same basic type of problem, just different numbers. So we're starting with $365. And then we're going to multiply that by the interest, which is 6%. Got to move that decimal to the left, so 0.06. And then it's figured after 4 months. And so 4 months out of 12 would reduce to 1/3 of the year. So 365 times 0.06 times 1/3, which when we multiply that across there, we get $7.30. All right, so number 10, Harriet earned $66 simple interest in 6 months at an annual interest rate of 3%. How much money did she invest? All right, so here we're trying to figure out what the number is that she put in there that she earned that much interest off of. So you got to keep in mind that simple interest is equal to the principal times the interest rate times the part of the year. So the simple interest she earned was $66. And that's going to equal the principal. I'm just going to call that P. That's what we're trying to figure out. How much money did she put in there? And the interest rate is 3%. So if we take 3 and move the decimal to the left, it's 0.03. 0.03. And then times what part of the year? Well, if we're looking at 6 months, 6 months is half of a year. 1/2. So we get $66 is equal to 0.03 times 1/2 is 0.015 times P. And divide both sides by 0.015. It's going to give us $4,333.33. Was her principal investment. Number 11, Angel deposited his $950 federal income tax refund check into his savings account. The account pays 4%, and he made no other deposits or withdrawals. How much is in the account after 3 months? So another of the same type of problem. So we got $950 is the initial, and we're not just trying to find the interest, we're trying to find how much is actually in the account. So we need to know the amount that he's put in there. So our new balance is equal to the $950 plus the amount of interest. And to find the amount of interest, it's the amount that we deposited, 950, times the interest rate divided by the part of the year, or times the part of the year. So it's 4%. So move the decimal 2 places. So 0.04, and then it's 3 months, which from the other problems we know 3 months is 1/4 of the year. So the new balance in the account is going to be 950 plus 950 times 0.04 times 1/4. Actually, multiply that out. That's going to give us 950. So the new balance in the account is 950 plus 950, $950 plus $9.50, I should say. So 959.50. All right, so Jamal deposited $1,200 in a savings account that earns 5% compounded quarterly. He made no other deposits or withdrawals. What is the amount in the account at the end of the second quarter? All right, so in this case, it's compounding quarterly, so we need to find the interest added into the amount deposited, and then since we're doing 2 quarters, we'll do that another time after we get the new balance. So we got $1,200, and it's 5% compounded quarterly. So times 0.05 when we convert 5% to a decimal, and then quarterly is every 1/4 of a year. And so we take the 1,200 times 0.05 times 1/4. It's going to equal $15 for that quarter. And then we add that in to the original 1,200, so that's going to be now for the second quarter $1,215. And then we're going to do the same process, times 0.05 times 1/4 of a year. It's going to give us just a slight bit more this quarter, 15.19. And add that to the 12.15 that we started that quarter with. So it'll be $1,230.19 in the account at the end of that period. All right, so 13. First savings pays 6% interest compounded quarterly on regular savings accounts. Angela deposited $1,500 for 2 years. She made no other deposits or withdrawals. Use table 1 to determine how much compound interest Angela earned. All right, so first off, before we can use table 1, which is actually on this page over here, we got to know what the interest rate is that we're using per period, and we have to know how many periods the interest is being compounded for. So the interest per period is 6% interest compounded quarterly, so 0.06 times 1/4 That's going to give us, actually I shouldn't have changed that to a decimal for this chart. 6% times 1/4, it's going to be 1.5. So that's the interest per period that we're going to look at on the chart. And then the number of periods that we are applying that interest, since it's applied quarterly, that's 4 times a year. And we're looking at it, the money being in there for 2 years. So 4 times 2 is going to be 8 periods. 1.50%. So then we come back to the chart. Yep. So table 1, 1.50% down to 8 periods is 1.12649. So that's the value of $1 after we have applied that many interest periods to it. And so once we've got that, then we take the amount in the account, 1,500 times the 1.12649. And simply multiply that through. I'm going to get 1689.74, which is the new amount in the account. The question is, how much compound interest did she earn? So I got to take that new amount, 1689.74, and subtract the $1,500 that she put in at the beginning. And so when we subtract that out, we see that she earned $189.74 in interest over 2 years period. All right, number 14. Nicole deposited $10,000 into a savings account paying 6% compounded monthly. What amount will she have in her account after 5 years? Using the formula A equals P times 1.00 plus R to the N power. All right, so first off, we've got the principal. The P is the $10,000 that she deposits at the very beginning. And then for the R, that's the rate per period that's being paid out, which it's 6% monthly. So 6%, when we convert that to decimal, is going to be 0.06. And monthly would be 12 periods a year. So that's going to be times 1/12, or 0.06 divided by 12. That's going to give us 0.005 for the R value. And then the N represents the total number of periods, which if we're compounding monthly, that's 12 periods a year. And we're keeping the money in there for 5 years. So 12 times 5, or 60 periods. So then we plug all that into that formula. The amount in the account is going to be equal to 10,000 for P times 1.00 plus 0.005 raised to the 60th power. raise 10,000 times 1.005 to the 60th. And type that into our calculator. A times 10,000 times 1.005 raised to the 60th power. And we get 13,488.50. So over 5 years, she's gaining $3,488.50. All right, so 15, Barbara has a principal of $750 in her savings account on January 1st. The money earns interest at a rate of 5% compounded quarterly. That's the amount in the account after 1 year, and use table 1. So, as a principal of $750, and before we can use table 1, we need to know the total interest periods. Which is 5% quarterly, so that's 4 periods a year, and we're only looking at 1 year. 4 times 1, or 4 interest periods. And the interest rate per period, well, the total interest rate is 5%. So change that to 0.05, and per period, since there's 4 periods per year, take 0.05 and divide it by 4, or multiply it times 1/4 if you want to do it that way. That's going to give us 1.25. Because once again, I change that to a decimal, and I don't need to do it here where I'm figuring out what I need to use on that table. So 1.25 for 4 periods. And so then go to table 1. So 1.25 at 4 periods is 1.05094. There. So the value of $1 from the table is 1.05094. And once we got that, it's simply 750 times 1.05094, which will give us 788.21. So that's how much is in the account after 1 year. All right, 16. Suppose you deposit $3,500 into an account that pays 5.5% interest compounded daily. According to the table below, how much interest will you earn in 30 days? And we're using table 2. So we're using the compounded daily table. Right here, so the amount of $1 at 5.5% compounded daily. It gives us the number of days, and then the amount of that dollar, which when I wrote this up, I didn't notice that this table went 21 to 25 and 31 to 35 and completely left off 26 through 30, which 30 is what we needed for this problem, which It's not on this table, but the number I give you for the test will actually be on the table. But for 30 days, it's 1.00452. I think there's another problem that I did the exact same thing. Didn't realize that it didn't give me all the days from 21 to 35 when I made up the test or the review. So we got the $3,500 times the value of $1 at compounded for 30 days, which was 1.00452. Multiply that out and we get 35, 15, 82. And we're trying to find out how much interest you'll earn, so we got to subtract the original amount of deposit out of there, 3,500, so $15.82 is the interest earned. All right, number 17. On April 30th, Sandra deposited $1,500 in a savings account that pays 5.5% compounded daily. On May 27th, how much interest had the principal in her account earned? Use table 2. Okay, on this, we're going to change that to May 24th because I didn't realize that the table did not include the day numbers 27 through 30. So, April 30th to May 24th. It's going to be 24 days compounded daily. And so we're going to come to the table. And so 5.5%, 24 days, 1.00362. So we're going to take the 1,500 times 1.00362. Multiply that across, and we're going to get 1505.43. Looking for how much interest she earned, so subtract the 1,500 from that, and we're going to get $5.43 in interest. All right, number 18. Joshua deposits $400 in an ordinary annuity at the end of each quarter in an account earning 4% interest compounded quarterly. According to table 3, what's the future value of the account in 2 years? So I'm going to find the total number of periods. So quarterly is 4 periods times 2 years. It's going to be 8 periods. And then it's 4%. And it's compounded quarterly times 1/4. It's going to be 1%. And so we go to the table 3, and we got 8 periods at 1%, 8.28567. That's the value of $1. So equal to 8.28567. So then from there, take the $400, just putting in there every month. Comes at 8.28567. We end up with $3,314.27. And that's the future value in 2 years. Phil had made $500 deposits in an annuity due at the beginning of each quarter in an account earning 6% interest compounded quarterly. Using table 3, what's the future value of the account in 2 years? So to do an annuity due, we start off doing it just like an ordinary annuity. So it's compounded quarterly, So, and we're looking at 2 years from now. So just like the last one, 4 periods per year times 2 years is 8 periods. And it's 6% this time, times 1/4, which will be 1.5%. So 8 periods at 1.5%. It's going to be 8.43284. The value of $1 is 8.43284. So find the value if it was just an ordinary annuity. So putting in $500 times 8.43284, and we multiply that out, we get $4,216.42. And then to do an annuity due, we take the amount that we've earned there, $4,216.42, and we multiply it times 1.00 plus that 1.5% converted to a decimal, so 0.015. So 4216.42 times 1.015, it's going to give us $4,279.67. And then number 20, and deposit $600 in an ordinary annuity at the end of each month in an account earning 6% interest compounded monthly. What's the future value of the annuity in 10 years? And using the formula, future value equals amount deposited. So the amount deposited is 600, and $1 plus R, and R is the rate per period. So it's going to be 6% divided by monthly, so that's 12 periods, so 0.5%. And then the N is going to be the total number of periods, so monthly is 12 times 10 equals 120. So, all right, so now that we've got those items figured out, we can plug it into the formula. Future value equals AD, which is 600, times $1 plus the rate R, which we're going to have to convert to a decimal, so 0.005. And to the N power, which is to the 1/20th, and then subtract $1 from that. And divide it by the rate of 0.005. So then we give us 600 and 1.05 to the 1/20th minus $1. It's going to be 0.819397 over 0.005. multiply that out, and then divide by 0.005, and we get the answer of 98,327 and 61 cents. So that concludes the review for Chapter 5. Good luck.